Welcome to the Infrastructure as Code module. So in this module, we'll build on whatever the digital transformation terminologies that we have learned in the last module to review IaC, which is Infrastructure as Code. We'll get introduced to a tool called Terraform, right, which helps in doing infrastructure as code. And then we'll dig deep into the Terraform concepts. So let's get started. So in this slide, we are going to quickly review infrastructure as code that we already saw in the last video. So infrastructure as a code very quickly is a very important agile methodology or a DevOps methodology, which helps to make sure that the development and operation seamlessly work in a highly agile software development process. So to quickly, so this is a great quote from Sam at Azure DevOps. So IaC model generates the same environment every time it is applied, right? So the consistency, because it's important because your infrastructure is going to go down and up. And then with cloud as well, you will realize that infrastructures, right? When we talk about infrastructure, we are talking about virtual machines, we are talking about virtual networks, the databases, the clusters, the Kubernetes, all of these resources, right? So the database, yeah. So all of these resources, you can sort of spin them up and also bring them down. So it sort of makes it easier in a cloud world so that you don't have to keep running these resources all the time, right? So infrastructure as a code involves more automation, so involves less human errors, right? So you know exactly what is the environment to be created in your staging or your production environment. Through that, it increases transparency. You know exactly what are the resources that are active. So the cost can also be evaluated. There is key traceability. So these are some of the features of your infrastructure as code. The traceability, how over so with infrastructure as code, we can also look at version control of your infrastructure, right? So you can look at traceability in terms of how many resources have you kept adding on over your application development process. Repeatability, which is what the code essentially says, because you can generate exactly the same environment every time. So if you want to spin a new cluster, you know exactly what is the resources that are required for a cluster. Of course, agility, suppose collaboration between ops, which is your operations, and dev. That's the very key point, right? And one of the very important part of infrastructure as code is a lot of times infrastructure documentation gets lost, right? Whereas if it's written as code, then it's trackable. You also have great documentation of infrastructure in terms of your code itself. So these are some of the key features of infrastructure as code. So now let's get introduced to IaC tool in the next slide. In this slide, we are going to talk about Terraform, which is a very popular infrastructure as a code tool. So it's an open source tool by HashiCorp, which is used for building. HashiCorp, so this is the official logo. So it's used not only for building, but also the evolving, changing and versioning of infrastructure safely and effectively, because a lot of infrastructure as code, as we have seen, not only has advantages in terms of your DevOps, but also your DevSecOps, the security part of it, right? Because as more infrastructure are getting churned, it's very important that the ports are managed properly, all of these, which is where tools like Terraform come in, because they bring in by making sure that you document all the infrastructure, the security, the safety of your infrastructure is also very important. As I mentioned, so when we talk about infrastructure, there is always a question in mind, especially for people who have not worked a lot on the development side. What exactly are we talking about? So infrastructure includes your virtual network, your VMs, virtual machines, your security rules for each of your services. So let's say you're using your S3 bucket, you have to explicitly set what is the security level for your S3 bucket, or your GCP, or your Redshift database. So if you're talking about AWS, then it's going to be your Redshift and your S3, whereas if it's GCP, then it is essentially a BigQuery and your GCS, which is your Google Cloud Storage, right? The containers, domains. So almost any infrastructure type can be represented as a resource in Terraform, which is the greatest part, because Terraform actually uses something called a plugin, which helps you to create these resources and the attributes of the resources. So it can manage existing popular cloud service providers as well as custom in-house solutions. So Terraform need not be used only if you have infrastructure on the cloud. It can also be used for your on-premise infrastructure management, right? So you will see in the subsequent slide, we talk about how a lot of service provider, not just the main three, AWS, GCP and Azure, but also multiple thing. There is a whole lot of CSPs like Pivotal, Snowflake, all of these upcoming cloud service providers who also seamlessly sort of help you to create resource using Terraform. So they have represented what's the code that needs to be done. So in Terraform, you write the language that is used to code, right? That is very important. You are essentially writing these configuration files which are declarative in nature, which means they are typically JSON like files, which tells the system essentially what kind of resources to create with what are its attributes, right? That's essentially, we'll take an example of that in the subsequent slides. So in this module, I'm not going to go into demoing in Terraform and going into it. This was meant as a module to understand other data engineering tools that are evolving in this space. So if you're interested, so I've given you the link to install Terraform on your machine. So go ahead and install it. So I have also given you a few references on how you can connect it, right? And some tutorials on what kind of things that you can do in reference, so that if you're interested to dig deep, you can get into it. So before we understand the Terraform concepts, it's first important to understand advantages of Terraform. Hopefully by now you are motivated by infrastructure as code. So what are the exact advantages? So it is results in infrastructure life cycle management. So previously there were, when we so you can see the sort of difference here, right? So previously it was SDLC, which is software development life cycle. Right now there is an infrastructure life cycle and management of it. So it controls the version control, so results in traceability, gives you a lot of these software engineering practices of rolling back, etc., which becomes now relevant for infrastructure as well. So very useful for stack-based deployments, right, which has multiple services that gets used from AWS or Azure, etc., right, with cloud providers. So it becomes very easy to sort of create infrastructure, destroy infrastructure. You can see that how Terraform helps you to apply infrastructure within few seconds, and then you can destroy the infrastructure. So because all of these, some of these services are pay as you go, right? So it's very important to ensure that you have the automation tool to destroy infrastructure as well. So it's a state-based approach to track resource changes throughout the deployment. So we'll talk a little bit about what do we mean by state when we look at some of the code later of how a typical configuration file is done. So it keeps track of, very similar to how the state of your code, right? So what are the delta difference in your code in a typical Git commit. What happens here is, if you're adding a new resource, then the state, so your current VM has only these resources, then the state, if you're adding a new resource, then you typically have to put it in your configuration file. So it understands that it's going to be a new resource, or one of the resources is deleted. So let's take a deeper dive into the Terraform concepts. So the Terraform configuration file is written in a declarative language. So the Terraform syntax is, as we have seen, both human and machine readable and writable. So it's in JSON format. So that the configuration file typically consists of two main files. One is main.tf, tf standing for Terraform, and variable.tf. So when you do, we see what are the commands. When you do Terraform init, it loads all the star.tf files, so all the .tf files in a directory, right? So codes written across, but we try to make sure variables are written in variables.tf, and all the other resources allocation are written in main.tf. So Terraform loads all the TF files in a directory. Almost anything can be declared as a resource. So that is the key advantage of Terraform. So it helps to take care or keep track of all the resources that are being used in the deployment of your application. So having understood the high level aspect of Terraform concept, so now let's dig a little bit deeper into Terraform resources, which is how do we actually write these configuration file like main.tf. So Terraform configurations are written in main.tf. So what it typically starts with, your main.tf file, it starts with configuration information. So here you can see that so you have you start with a Terraform, so it's a JSON format. So you have what are your required providers, what's your backend, right? Here in this case it's local. You can change it to your cloud-based infrastructure as well, right? So it defines the provider. So what all needs to be defined in your configuration main.tf file. So you start with configuration. So this is your configuration information block. Then it digs deeper into the provider, right? It is responsible for understanding the API interactions and exposing resources. So it's very important to, when you're writing your script, also give Terraform the authentication with specific access control, all right, which is very, very important, because security is a very, very important. You don't give admin access every time. You have to give only read access for certain resources, maybe some commit access to certain resources, right? So the provider here is Google. Right, so we are saying project is var.project. So all of this, var is variable. So the variable, we'll talk about the variable file. So it is all defined in the variable file. So you can also give credentials, which is your typical key that gets downloaded from your GCP, right, which is stored in the folder. So then you go ahead, so you start with your configuration information, give you provider, and then finally list the resources. In this case, if you are creating a BigQuery resource, so that is what it's saying. Your data set is your BigQuery data set, which is created with project, and what is the location in which this is created. Right, so providers are essentially, so providers can be your infrastructure as a service, or your platform as a service like Heroku, or your SaaS services like Google. So Terraform, it's important to understand that Terraform is built on a plug-in based architecture, right? So what that means is all providers and provisioners used in Terraforms are plugins. So users are able to write new plugins in order to support new functionality in Terraform. So if you have a new cloud service provider come in, they can write their plugins so that it can be created as a resource in Terraform, right? So it's extendable in that way. So we'll see how these plugins work in the next slide, so that you know what, because all of these code are actually available, which you can use to configure your resource. So having understood how the configuration main.tf works, so now let's take a deeper look into your main.tf. Refer to a lot of var.project, var.region. So where are all these variables defined? So we need to define these variables. So variables are typically to make your configuration truly shareable and version control. It's a way to parameterize, right? So that you have a single place where you can change. For example, if your version needs to change, region needs to change from Europe West to Europe East, or from Asia East to Asia West, etc. So you can just change it in one single location, right? So it's important. So we already know what are the advantages of using variables having been coders. So variables are used for some of these configurations. So you have what is locals. So if you are using data lake buckets, so it actually refers to the project name. Right here, and then the variable project refers to your so there are descriptions, and then you also have default, right? So default is the value that gets used. So region in this case is Europe West. Storage class is standard, and your big data query is trips all. So this Terraform file actually comes from a data engineering Zoom camp repository, so the link of which has been given to you later, so you can go and look at it, of how these variables sort of come together. I have also given you the links to the demo videos, which you can use if you are wanting to get a little more hands-on with Terraform. So variables are used for inputs that could change, or to avoid hard coding of your keys and secrets, right? So you just have to change in one place, and then it helps you to make sure that the rest of the place it gets reflected immediately. So it definitely helps at runtime. So having talked about main.tf, your variable.tf, let's look at outputs.tf. So outputs are a way to organize data to be easily queried and shown back to the Terraform users, because not all the attributes are required for the user, right? So if certain things like the IP of a certain resource needs to be sent back to the system admin, right? The operations person, because they need to use that ID. So essentially you specify in the output file. So Terraform uses multiple attributes across all the resources. However, only a few values may be of relevance to the data engineer: the IP address, the VPN address, etc. So all of those are essentially, we say, hey, what are the values that needs to be shown back to the Terraform users, so that it can be of access for the rest. And these are usually mentioned in an output.tf file. So earlier when we talked about Terraform features, we talked about it keeps track of the state of the infrastructure, right? So that's very important. So Terraform stores the state of the managed infrastructure and configuration. So that makes it easier to track, right? The state is used by Terraform to map real world resources, which are essentially your virtual machines or your Kubernetes clusters, etc., to the configuration return, and keep track of the metadata, which are data about the resources, and improve the performance of large infrastructure. So we can sort of keep track of, hey, if you are defining a certain infrastructure for certain kind of load, then if you want to change it, then how does it impact, right? How many users were able to effectively come in, was it able to manage traffic, etc. So you can do all of that because your infrastructure is tracked, right? So that's essentially the Terraform state uses to track the infrastructure changes. So finally, now we are going to take a look at the 5 key execution steps that are used by Terraform. Right, so it's very similar to your Git. If you have seen the Git video, right, you will see a lot of parallels to it. So you start up by doing, once you install your software, you do a Terraform init, which essentially says that, hey, this folder is going to have all the configuration information needed for managing your infrastructure. So initializes and configures the backend, installs the plugin, and checks out all the existing configuration from a version control, right? So once you do that, what happens is you can do a Terraform plan. So plan is essentially a dry run of the resources. And specifies how many resources will be added, right? So it's essentially a creation plan, which is sort of, you can correlate it with how your lazy execution happens in your Spark, right? So you don't go ahead and execute the entire thing, but you just first make your execution plan. So your Terraform plan matches and previews the local changes against the remote changes and proposes a execution plan. So this is just the plan. The resources are not actually created at this step. So it's a plan to create the resource, but you need a plan in order to execute it, right? So it sort of gels so beautifully well with how we think about. And then you do a Terraform apply, where it actually asks you approval for the proposed plan. Okay, so I'm going to go ahead and create this infrastructure. Are you okay with it? And when you say yes, it goes ahead and applies the changes to your cloud or your on-premise infrastructure. You can certainly use Terraform not only on cloud, on your local infrastructure as well. Your reference has a few where you can use Terraform to create databases in your local Postgres DB as well. Right, and especially when you're using cloud, it's very important to destroy resources, right? So when you say Terraform destroy, it removes the stack from the cloud. So this becomes more and more relevant because we, as I previously mentioned, cloud resources as pay as you go. So this helps us to keep track. So you can do your work and then bring it down and then create exactly the same infrastructure by doing a plan and apply the subsequent day. So it will exactly create the same environment every single time, which sort of ties back with the code that we started this module with, right? So IaC helps us to create the same environment every single time. All right, yeah. So these are the execution step. So there are 4 of them. So you can see it has correlations with how Git works and also in some way how Spark works. Well, to summarize, we reviewed infrastructure as code. What are the advantages of it? Why does it make sense in the agile methodology as a DevSecOps tool? And then we got introduced to Terraform, which is an open source tool that helps us to maintain infrastructure as a code, because it's going to create a code for every resource that we use. So it could be local, it could also be on the cloud. And then we went on to understand a lot of concepts of Terraform in terms of how the configuration files are typically written, what is the structure of them, etc. So there are a bunch of reference slides that I have put in, which helps us to dig deeper into Terraform and also give some YouTube links on how you can enhance your learnings better. All right, I will see you in the next video. Thank you.